Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 12th of June 2025, T 9 hours, 29 minutes, and 16 seconds, 0.000 Z. This was published just a few days ago, and it reveals that even the best models struggle with complex scientific tasks, with the top performers scoring just over 34%. The paper is titled, Scientist's First Exam, Probing Cognitive Abilities of MLLM via Perception, Understanding, and Reasoning. So the authors argue that we aren't testing our scientific AI models correctly. They say current tests focus too much on just knowing facts. To fix this paper introduces a new benchmark called the Scientist's First Exam. It's designed to evaluate multimodal large language models, which are AIs that can process both text and images, on their ability to perceive, understand, and reason about real scientific data. They pull from 5 different fields, like astronomy and chemistry, and as we'll see, the results show there's a huge room for improvement. Alright, so this figure really shows us the architecture of the scientist's first exam. On the left, you see the raw data they use, everything from molecular structures in chemistry to spectral data in astronomy. But the core idea is on the right, where they detail the 3 cognitive levels of questions. It starts with signal perception, which is basically just identifying what's in an image. Then it moves to attribute understanding, which requires analyzing properties. And finally, the most complex level is comparative reasoning, where the model has to compare options and make a logical deduction. Building on those cognitive levels, this next figure details the meticulous framework for actually creating the benchmark. It's a 3-part process. First, on the left, is structure construction, where experts define key scientific problems. In the middle, task construction shows how they map those problems to the different cognitive levels and question types. Finally, on the right, benchmark construction shows how raw scientific data is visualized, paired with questions to create what are called visual question answering pairs, and then rigorously reviewed. The whole process emphasizes expert validation at every step. Moving to the results, this table shows how 16 different multimodal large language models performed on the exam, breaking it down by scientific field. They use what's called an MLLM as a judge score, which is where a powerful AI evaluates the answers. The big takeaway is that the scores are quite low across the board. The best model, GPT-03, only scored about 34% overall in English. We also see a clear difference between fields. Material science was the easiest, with GPT-03 hitting over 63%, while astronomy proved the toughest. This next table then gives us a more granular view, breaking down results by the 3 cognitive levels and different question types. A key insight is that newer models like GPT-03 show a big jump in reasoning ability, scoring over 36% on the L3 reasoning tasks, a significant leap from older versions. This suggests improvements are in reasoning strategies, not just knowledge. The results also distinguish between closed-weight models, which are proprietary, and open-weight models. And for evaluating answers, they use metrics like BERT score, which measures semantic similarity, not just exact words. So to wrap things up, the big takeaway here is that even the most advanced multimodal large language models have a long way to go in genuine scientific reasoning. The best scores were still quite low, showing a clear need for improvement. But importantly, the results suggest new models are getting better at complex comparative reasoning, not just knowing facts. The study also uses metrics like pass at K-scores, which check if the right answer is in the model's top few guesses. This work really sets a new standard for testing AI in science. That's all for today's roundup. Thanks for tuning in.